Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
Hi, so we're going to try to solve a statics problem, statics homework. This is the homework over here. It's got 5 problems and they are in each page, 1 in each page. So we're going to tackle the first problem here. It's got 2 forces with angles, one with the x-axis, one with the y-axis, and the magnitudes are given. And we have to figure out the resultant forces when they're added and subtracted from each other. So let's start with the first force, F1, and I'm going to use Matlab over here because Matlab is a good way to handle vectors, and it's just used for calculation purposes. So I'm going to type in the force 1 magnitude over here. Let's call it mag, and let's say it's 2.14, and because it's kilonewtons over here, I'm gonna write 1,000, and out here you're gonna see F1 mag has 2140. So same thing, I'm gonna do F2 magnitude equals to 2.98 times 1,000, and that gives me the magnitude for F2. And you see the variables are stored here for later use, so we can use we don't have to type in the number like here. We can just type in F2 mag for F2 magnitude. So now I'm going to type in the angle that F2 has. F1 has. F1 angle is 53 degrees from the x-axis. So it is going to be F1 angle. So F1 angle equals to 53 degrees. Now I want it in radians instead of degrees, so I'm going to convert it directly into radians. So this would give me multiplying by pi and dividing by 180 will give me the angle in radians, and that is 0.925. And I'm going to do the same thing with F2 angle, but F2 angle is with the y-axis, and it's not from the x-axis. So what I'm going to do is I'm going to add 90 to F2 to get the right angle. So it's going to be 31 in a bracket, 31 plus 90. So we're adding 31 to 90 to get it from the positive x-axis in a clockwise direction. So that would give us 2.1118. Now what we can do is we can put in these numbers into a vector form. So the way I would do that is I would write just F1, this is the vector, is equals to the F1 magnitude times, so in Matlab this is singular multiplication, scalar multiplication in a vector format. So I'm going to type in the vector here. So the first vector is the x-axis, it's cosine of F1 angle, and the next one is going to be the sine of the F1 angle, and close this. This should give me right. So this is the vector over here, and this is multiplied by 1,000 to give me the newtons. We're going to do the same thing for F2. F2 is F2 mag times the F2 angle, the cosine of the F2 angle and the sine of the F2 angle. And that would give me this. And that looks correct because this is negative on the x-axis, positive on the y-axis. So that's correct. So now what we're going to do is we are going to add R1 equals to F1 plus F2. That would give me the resultant vector in vector form. So this is the resultant vector in vector form. We see that this is still slightly negative in the x-axis. So if we want to get the magnitude of it, we can get the magnitude of it. So R1 mag equals to norm. It basically forms the magnitude of a vector, and that would give me 4,270.6 newtons. And next, what we're going to do is we are going to find the angle. The way we find the angle is so the easiest way to find the angle is going to be to convert this 2D vector into a complex number and find the angle for the complex number. So the way we convert it into 2D is basically write the complex number like so. R1, the the x-axis, plus the complex part, the imaginary part is going to be R1, 2. So that would give me a complex number like so. And so now that we have the complex number in position, we can find the angle. R1 angle equals to angle of R1 Z. And I'm gonna convert this into degrees, and that should give me the number in degrees, and that's almost correct because this is slightly above 93 degrees. So this is R1 mag is the magnitude, and R1 angle is the angle from the x-axis for the first answer over here. So we have this and we have this, and we need to divide by 1,000 to get the answer over here. So what we're going to do is R1 mag in kilonewtons equals to R1 mag divided by 1,000, and that's the answer. That's the answer that you put in here, and this is the counterclockwise one is going to be this one. So that's the final answer for A. We're going to tackle R2 equals to F1 minus F2, so we're going to do that now. So we can just copy this one over here, R2 equals to F1 minus F2, and that gives us R2. And we can copy the R2 mag from here, and this is R2 mag. And remember, R2 mag, I need it in kilonewtons, so this is the answer. This is a kilonewton answer. And then, well, then we can do the R2 angle. So we get the complex number out of.
Think Geek exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.